This is Algebra 2, Lesson 52 on page 226. All right, guys. Everyone needs to pay attention because I am not going to teach this like the lesson, like the textbook. And that should be no surprise to you, right? At this point, you should not be surprised. I don't like the way the textbook teaches this. They do this pour and dump method. Invariably, I have a student that works at pour and dump. Don't work at pour and dump. You're like, what is pour and dump? I don't know. That's good. Forget it. Right? Okay. I want you to work this problem like our monetary problems. So I want you to think monetary. Remember how we had nickels plus dimes equals how many? Like how many that I had, right? And then I did 0.05 plus 0.10 equal to how much? Like the value was, right? Okay, this is gonna be similar, except it's with chemicals, and we're mixing chemicals. All right? So here's just an example, and then we'll work the ones in the books. All right, let's say I have an ammonium, but it's 10% ammonium. All right, so if I have a mixture and it's 10% ammonium, then the rest is water. Do you know that? Like when you buy any cleaning solution, the majority of that cleaning solution is water. The rest is chemicals.
Unless you just buy pure chemicals.
If you do the pure chemicals, you're ruining everything in your home. Right? Okay, I'm just telling you, right? I mean, even when I clean with vinegar at home, I dilute it with water. Did any of y'all use vinegar to clean with? You don't pour direct vinegar on your floor and mop. Please do not be doing that.
Or put it in the microwave.
Or put it in the microwave for whatever reason. Okay. All right. So here we go. So I want to go ahead and lock that concept in your brain. If I have an ammonia that's 10%, then what's the water content? 90. Okay, we're not going to use that today, but we're going to use that. Let's say I have an ammonia let's call it alcohol, 10, rubbing alcohol. And let's say I have rubbing alcohol that is 50%, and I want to combine those two concentrates such that the end result is an ammonium or an alcohol that is 30%. Okay? Well, I can figure that out. But you're always going to have these represent how many grams of that I have. So I'm going to add those together. Some mixture of the 10. The 10's going to dilute the 50 such that I end up with a 30. You get it? That's like the how many grams. All right? The how much is going to be by weight. Or how much concentrate. So then we're going to take the concentrate and multiply it by how many grams we have. You see how this is so similar to the money? We're going to take the concentrate, multiply it by how many grams we have. We're going to take the concentrate, multiply it by how many grams we have. Does that make sense? So you see the similarity? Yes, Therese?
So in the formula on top, are you trying to end with a certain amount of grams, or is it just the concentrate that you're worried about?
I'm not worried about the concentrate here. I'm just worried about if I weigh it, how much do I have?
Do they give you any weights?
Okay, yes. So this is just setting it up to then look at a real example, right? I want you to see that it is just like this. We're going to work it the same way. But now it's with liquids, so I can't count like I can count coins, right? All right. So let's look at a real example, 52-1. We're always going to have how many equations? 2. One is going to be just how much of each substance I have. One, we're going to take the concentrate and multiply it by how much of that substance we have. Got it? Okay. All right, let's look at 52-1. A druggist has one solution that's iodine 10. I'm going to label that I sub 10. I know it's iodine. I know the concentrate is 10%. And another that is iodine 50, I'm going to label that iodine 50. How much of each should the druggist use? So he's going to use some of each so that he gets 100 milliliters of iodine 20. So how much of iodine 20 do I have?
100 milliliters.
Part of that's going to come from the iodine 10. The other part's going to come from the iodine 50. I don't know how much of each I'm going to use. So I'm going to say the iodine 10 plus the iodine 50. I'm going to end up with 100 milliliters when I combine them. So now we're going to figure out how much of each does the druggist need. Then I take the concentrate, multiply it by how much iodine 10 I need, plus the concentrate, multiply it by how much iodine 50 I need. What concentrate do I want? 20%. So I take the concentrate. How much do I have in the end? 100 milliliters. So our answer is going to be in milliliters. You see how I wrote this? Very close to the money problems, except now it's percents. All right, in the second equation, I end up with 2 variables. How do you think I'm going to solve for them?
Well, so is I like the
Sub
amount?
10. Yeah. How many milliliters?
Okay.
How many milliliters? How many milliliters? Now I'm taking the concentrate times how many milliliters?
Okay.
Yes.
So you could do, so you replace I10 with 100 milliliters minus, like, I.
That's right. I'm going to take this first equation, solve for one of the variables, and then substitute. Yes. So we're going to solve for I10 by subtracting I50 on both sides. So I know that how much I10 I'm going to have is going to be what I want in the end, the 100 milliliters of the I20, minus how much I50 I have. Just like nickels and dimes, right? If I said the number of nickels plus the number of dimes is 10, isn't it true that the number of nickels I have is going to be 10 minus the number of dimes? It's the same, except it's not individual units. It's a liquid measure. All right, so for I10, this is what I'm going to substitute in. All right, so I have 0.10 times 100 minus I50 plus, I'm going to go ahead and eliminate the parentheses, 0.50 I sub 50 equals, I can do this calculation. What's 0.20 times 100? 20. All right, distribute this 10, 0.10. What's 0.10 times 100? 10 minus 0.10 I50 plus 0.50 I50 equals 20. Yes, Therese?
And could you work this problem by, like, could you multiply the whole thing by 100 first? So you could be working with, like, 10 and 50.
I don't ever work that with this because we end up, I would not, because you have some inside parentheses outside. Don't eliminate the decimals here. All right, subtract your 10 because you end up with a decimal times the substance equals a whole number most of the time. So subtract your 10 from both sides. Let's combine our like terms. What is 0.5 minus 0.1? That's right, it's going to be 0.40 I-50 equals 10. Divide both sides by 0.4. How much I-50 do I have? What's 10 divided by 0.4? What is it? It's 25. It's divided by 0.4. Okay, look. Y'all look at this. Here's how I saw this. I just added a 0 because that was my decimal. And then I eliminated the decimals. And I know 4 went into 125 times. But do the division on your calculator, right? So if I need 25 milliliters of I-50, how much of the I-10 am I going to need? 75. Is that logical? Were you expecting me to need more of 10 than the 50 to get to 20? You should. Because we're diluting that 50 down. Make sense? See how that is logical? All right, look at the second example. All right, you're sort of letting this sit a little bit.
Wait, how'd you get the 25?
10 divided by 0.4.
Okay. What if you get a decimal number or a fraction? Then it'll just be...
You might get 6.5. But that's the rare occasion. Most of the times, this value is going to be a whole number, no decimals.
So if you did something wrong.
Probably so. Yes. Yes, Jesse.
When you multiplied 0.20 by 100 on the up there, what did you multiply by 100 on the other side? Or did you?
Well, for I-10, I substituted this in. All right. So then I multiplied that 10.10 times 100 to get 10, and 0.10 times negative I-50 to get negative 0.10. All right, we're going to work another one. Remember, you're always going to have two equations. One is going to be like the weight of it, and the other we're going to take that weight and multiply it by the concentrate. Got it? One's going to be the weight. One's going to be the weight multiplied by the concentrate. And we're always going to use that first equation to substitute into the second one. Always.
What does it mean?
All right, let's look at the second example. A chemist has one solution that is salt 10. So it's salt 10 and 90% water. I just needed the salt 10. And another solution that is only salt 2. How many millimeters of each should the chemist use to make 1,400 milliliters of salt 6? I want to end up having salt 6. So I'm going to combine the 10% and the 2% to yield a 6%. He needs 1,400 milliliters of the 6. So I'm going to go ahead and substitute that in for salt 6, because I know that's how much I want to have in the end. Now what do I do? Ashley?
You would find what salt 10 equals.
Okay, I can. Salt 10, I'm going to subtract salt 2, is 1,400 minus salt 2. All right, but what's my second equation? Do y'all know the second equation? Therese does. Anybody else? Anybody else? Do y'all know? Are you anticipating? What am I going to do? I'm going to take the percent in decimal form, multiply it by however many milliliters. The percent in decimal form, it's O2. Notice every percent I'm writing with 2 decimal places. Always. For this very reason. times salt 2 equals, this percent is going to be 6. What am I going to multiply it by? I know I want the 1,400 milliliters. Are you following me? For salt 10, I'm going to substitute 1,400 minus salt 2. So I'm going to take 0.10 for salt 10. I'm substituting in the 1,400 minus salt 2 plus 0.02 salt 2. What's 0.06 times 1,400? 84? All right. What is 0.10 times 1,400? I distribute that 0.10 to both of the terms. I'm going to subtract the 140 from both sides. What is negative 0.10 plus 0.02? Negative 0.08. Okay, this is why we have two decimal places. Here's why. If students just write 0.1 and 0.02, they end up with like 0.1 because they're not considering the position of the digit. All right, make sure you have both of those digits. Okay, S sub 2 equals, what's 84 minus 140? Negative 56. Divide by negative 0.08 on both sides. And how much S2 did we have, Nora?
700.
We have 700 milliliters of S2. If I have 700 milliliters of S2, salt 2, how much is salt 10? Same. Is that logical?
I guess.
6 is exactly the midpoint between 2 and 10.
Huh.
Right? So you're going to have equal amounts when your solution concentrate is the midpoint of the two solutions you have.